one final method in order to find the uncertainty of a certain expression is called the foundational method. Now, this is actually very important when you have some expressions that may look something like this. So one of the clearest examples of this is when you maybe have two resistors in parallel, okay, R1 and R2, and you need to find the effective resistance of this thing. So we know that R effective is basically R1, R2 over R1 plus R2. Now let R1 be 5 plus minus 0.1, and let R2 be 3 plus minus 0.2. Now, one thing that we want to notice here is that we can see that the same expression or same variable is on both the numerator and denominator of this expression. And whenever this happens, you must use the foundational method. So what exactly is the foundational method? So we're going to literally try and figure out what is the maximum value that R can take, R max, and what is the minimum value that R can take. Now, first of all, let us first understand what R is supposed to be just using the normal values. So we'll go 5 times 3 over 5 plus 3. Okay, and if we work this out, you'll get about 1.875 ohms. Now, how do I maximize R? Now, because this is a multiplication and this is an addition, multiplication is more powerful than addition. And so to maximize this, you want to make the numerator as large as possible. And so what we do, we choose the maximum possible values that R1 and R2 can take. So this will be essentially 5.1 multiplied by 3.2 over 5.1 plus 3.2. And let's do the calculation. Okay, you will get, let me see, about 1.966. And of course, if I want to minimize this expression, then I choose the smallest values that these can take. So that would be 4.9 times 2.8 over 4.9 plus 2.8. And if we work this out, you will get about 1.782. Now, we can now calculate delta R, okay? And basically the way of thinking of this is that, well, I've got R max here and R min here. I want to calculate what this value is. And so we take the difference between R max and R min and divide by 2. So delta R is 1.966 minus 1.782 divided by 2. Okay, and you will get about 0.092. And so therefore, R with its uncertainty can be expressed as 1.875 plus minus 0.092. And of course, we have learned before that this has to be brought to 1SF. So this will be 0.09, and this will be given to 2 decimal places, so 1.88. This is how we do or use the foundational method. And once again, let us remember that this must be done, especially in situations where you have the same measurement in both the numerator and denominator of the combined expression.